Today we're going to be talking about finding the vertex of a quadratic function if it's written in standard form. So yesterday we were talking about vertex form. It's pretty simple because it was basically given to us as the problem was written. But now the problem is going to be given to us in standard form, which again means that it's in the form ax squared plus bx plus c. Now, this math here shows how they derive a formula for the x value of the vertex here. And the important takeaway is what they end up with down here, the formula for the x value of the vertex, which again is h because the vertex is h comma k. So this formula here is very important to remember, and all we have to do to use it is recognize what is the a value that's given and what is the b value that's given, and then plug in the x to find the y value. So let's see an example. So in this given problem, we want to know what the vertex is. I'm going to remember the formula. The x value of the vertex is negative b divided by 2a. And so how do we find b and a? Well, if I come here and compare this to the standard form, and look what is in spot of the a, the b, and we don't need the c, but I can see what's in spot of it. In the place of the c is 10, in place of b is negative 6, and in place of a is actually a 1. Because a, b, and c will not be the x. A, b, and c are just numbers that are going to be given to you in the problem, and if you don't see it, then it might be a 0 or a 1. Okay? If I didn't see this 10 at all, I would know that my c is 0. Or, in the same case, if I didn't see the b value, or if I didn't see that middle term at all, I'd know my b was 0. But in this case, a is 1, b is negative 6. So if I plug that in, I get my h value is going to be negative 6 over 2 times 1, which is going to give me 3. Remember, double negative is going to cancel out. Now, once I have the x value of the vertex, I need to find the y value, and they were nice enough to give me an equation to do that. So if I plug in 3 for my x's, I will have the equation 3 squared, which is 9, minus 6 times 3, which is 18, plus 10, and putting that all together gives me a positive 1. So, my final answer, my vertex is at the point 3, comma, 1. So, how can I use key features to graph a quadratic function? Well, the key features of a function would be the intercepts, and the key feature of a quadratic function would be its vertex. So, we don't know the x-intercepts, but we can find the y-intercept easily enough here when it's written in standard form. Because remember, the y-intercept is where x is 0. So to find out what the y-intercept would be here, all I have to do is plug in 0 for x, and I get 0 squared minus 4 times 0 plus 8, which is 8. So, an easier way to find the intercept of a quadratic, though, instead of plugging in 0 for x, is just realizing that the constant term at the end, when it's given to us in standard form, is going to be my y-intercept, because those first 2 terms are just going to go away. So here, if it's given to us in standard form, I can see the y-intercept given to us, And then the other key point that I want is the vertex, which, again, I'm going to have to use the formula negative b divided by 2a. And I'm also going to have to identify here that my a is 1 and my b is -4. So plugging that in, I again, doubling up on the negatives, 2 times 1. So I'm going to get my x value is 2. And to find out what my y value is at the vertex, I need to plug in x is 2. That's going to give me 2 squared minus 4 times 2 plus 8. So that's 4 minus 8 plus 8, or 4. So my vertex is at the point 2, 4. And my intercept is 0, 8. So I'm going to go up by 2's on my graph. 2, 4, 6, 8, 10, 12. Same on this axis. 2, 4, 6, 8, 10, 12. And if I plot my intercept, it's going to hit the y-axis at 8. My vertex is going to be 2, 4. And if I want another point, remember, the vertex is where my axis of symmetry is going to be. So any point on the left is going to be reflected the same distance away from the axis of symmetry on the right. So once I have the vertex and a point off of the vertex, I can just mirror that other point and get my final parabola to look something like this, roughly. So, same method that we used for this first problem, just find the vertex, and we're also able to find the y-intercept easily enough when it's given to us in standard form. Now you may also have to interpret a graph and what it means to be a vertex. So here we're given a height of a water balloon over time modeled by a function. We want to know the maximum height of the water balloon. This is asking us to find the vertex. So here it would be the same as the last two problems. You would want to find out what the value of h is, and then plug it into the function to get out your y value. So same problem, just different interpretation. And the last thing we're going to look at is finding the equation of a parabola given 3 points. So if I'm given 3 points and I want to find the equation of a parabola, my 3 unknowns that I need to find are A, B, and C. And if I have 3 unknowns, I need 3 equations to solve for those unknowns. So going back to a system of 3 equations that we looked at in the last chapter, and we can solve those with matrix technology. So if I plug in my given xy, so remember, if I'm given 3 points, I'm given an x and a y, an x and a y, and another x and a y. I can plug these in to my equation 3 different times and simplify. And when I do that, we get a system of 3 equations, which, as I remember, we can write as an augmented matrix, just that I have to put these answers on the right side of this. So this matrix would look like 4, -2, 1, 32, 1, 1, 1, 5, and 9, 3, 1, 17. And once I put that into the matrix calculator, and I put it in the reduced row echelon form, we'll get out my values for A, B, and C in the final row, and it tells us A is 3, B is -6, and C is 8. So to get our final answer, we're going to plug those in for A, B, and C. So again, the idea here is plug in the 3 given values, simplify to get an equation, and you repeat that 3 times. Use the matrix calculator to tell me my A, B, and C value, and plug it in to finish the equation. And let's see what one of those looks like. So remember, my first step, I'm given 3 sets of x and y's, and I'm going to actually put those in different colors to demonstrate my different equations here. So plugging these into the equations, my first one would become -12 equals A times 2 squared plus B times 2 plus C, which simplifies to -12 equals 4A plus 2B plus C. My second equation becomes -15 equals A times -1 squared plus B times -1 plus C, which simplifies to -15 equals 1A minus 1B plus 1C, or just C. Remember, you don't really have to write 1A or minus 1B. You leave the ones out. And my last equation I get from plugging in -4, -90 to be A times -4 squared plus B times -4 plus C, and that simplifies to become -90 equals 16A minus 4B plus C. So now with these 3 equations, I can write my augmented matrix, remembering these answers need to be on the right side of the matrix. But if I put it into matrix form, these equations become 4, and then I'll put these in the colors that match. So I have 4, 2, 1, -12 is my first equation. My second equation is going to be 1, -1, 1, -15. The third equation is going to be 16, -4, 1, -90. And so remember, if I want to utilize the calculator on this problem, so remembering to use the calculator on this problem, the first thing you're going to do is go into the matrix menu by hitting second to access the matrix menu. Going over to edit the matrix, we want to put in a 3 by 4 matrix, and the entries are 4, 2, 1, -12, 1, -1, 1, -15, 16, -4, 1, -90. Once you've entered in the matrix, you're going to quit back to the home screen. Go into the matrix menu again, but this time we're going to math, and we're going to select row ref reduced row echelon form. Once I've selected that, I go into the matrix menu a final time to select the matrix I want under names. That's the first matrix, so I'm just going to enter. Enter one more time. And remember, these values are my answers if my rows read 1, 0, 0, 0, 1, 0, 0, 0, 1. Because as an equation, this would represent 1a plus nothing equals -4. 0a plus 1b plus 0c equals 5. 0a plus 0b plus 1c equals -6. So I know my a, my b, and my c. My final answer then becomes y equals -4 x squared plus 5x minus 6.